Okay, hello, how are you? My name is Hang Zhao. This is the class about CSE uh, 5, CSE, I think it's 5, 6, 4 visualization. And this is project 2 uh, given by instructor Klaus Muller. And my ID number is 112524698. Okay, so this is a second project. It's about using the same data set from the project 1 to implement several requirements like data clustering and decimation and the dimension reduction and the visualization. So the purpose of this project is to get full use of the data from the project 1 and use D3 as a tool to visualize like k-means, PCA, and MDS with the original data, random sampling data, and stratified data set. The requirement of the data set is at least 500 points and with at least 10 dimensions, where it is enough to produce a satisfying visual effect to us. So with the data set, the project from 1, so I use the same data set about the baseball data set provided by the professor. So this since this time we will combine using the Python and D3 together. So we need to the Flux library to transfer from the data from the back end to front end in order to constructing graphs like a scree plot and the scatter plot in D3. So let's begin. Firstly, I want to show you the website. Here, this is the website I constructed. So firstly, we obtain the original data set, and we have the random sample data set, where the different from original data set is that we seldom choose the half size of the original data set and implement in the same graphs to see that's different. On the right hand side, here is because the athlete they have the left hand. They use the left hand, their left hand, their right hand, or their both hand. So it's different. This is the original data, and we also have the stratified data set. So this is actually using the k-means analysis method. So how we find the best case, we use the eyeball method here. We try different k to the data set to find out which is the best for us. It doesn't mean that it has most least distance, like you can see here, the 9 number has a least distance, but it's not what I want. What we want to is the eyeball. Eyeball means that we choose the point that's like a transfer point here. In this graph, I choose the number 4 here. Exactly when the k is equal to 4, so we can see that our stratified data, I'm labeling them into 4 different groups. So the color is shown in the right hand side. So because there are 4 centers, and they found out their groups in the data set to show the difference of different groups here. After this after this, the second task is to find intrinsic dimensionality of the data using PCA. So PCA, that's from actually from the Python functions to find that. Let me find out the Python code. Actually, it's here. It's PCA here. Actually, this part. When I implement the n is equal to false using decomposition method to decompose the original data set here into the matrix, into the main matrix. From the main matrix, we can get different vectors in a descending order according their their values, because for the first vectors it has the highest value, because it is very important to the original data. That is why it called it principal component analysis. So we can see from the data set here, when the vector is equal to 1, actually it has the largest value here, percentage. It's like you can see it from original data set PCA. We can see it's almost like 50% from the first one, and for the second one you can see it's like it's decreasing to like 35%, and it's in a descending order, you can see. But it's different from the stratified data PCA and the original data PCA and the random sample data PCA. You can see the graph here. Actually, the random sample data PCA is more likely to close to the original data PCA, because you see the random sample is part of the original data, so it belongs to the original data, so they share a lot of common here. But the stratified data, we just choose one of them, so it shows a lot of different here. So that's the part. That's the I think that's the different part. So we use these graphs to compare with each other. And next thing so this is the mark the difference. So next thing we need to scree plot the graphs to show the piece. I think yeah. So this is the scree plot. This is the scree plot actually. So first what we find the intrinsic dimensionality, and second we mark the dimensionality. So third, so we plot the graphs here. So next thing we need to visualize the MDS using by using MDS to see the difference among the graphs. So firstly we implementing MDS in the original data, so we can see it maintains the distance of each point to show the graphs, even though we reduce the 4 dimensions into 2 dimensions, so it still keeps their difference here. That's a good thing. But badly MDS cost a lot of time to compute the distance among each point, so it will spend a little more time. The next thing is MDS with random data set. You can see it's the same graph, but with a little less points here. But it still keep the distance here. You can see the graph is keep very good at this. But another thing is we use MDS with stratified data group. You can see use the original k-means method. We keep to use it, but use it in the MDS graphs, so we can see the different groups here. It maintain a very good maintain the shape. So, but compared to the PCA, So PCA, you can see PCA screen plot here with the first two vectors. First two vectors you can see here. The shape is not as good as MDS with stratified group. You can see it's a little change the little shapes here over here. But PCA actually is using the first two highest value vectors and plot them into the x and y axis to see the scatter plot here, but it's not as good as the MDS. But it's always still has its advantage because it costs less time to compute. So next thing is the task 3. So we already show the top two PCA vectors, and we already show the MDS 2D scatter plot, and finally we use the scatter plot matrix. This is a little spend a lot of time to do that because visualize the scatter plot matrix of the three highest PCA. Needed to load the attributes of the three most highest PCA. This is the method to show the different variables through plotting scatter plot among multi-variable, and it is useful to analyze data in a more precise way. Firstly, we need to find out the name of the three highest PCA attributes. Like here, we can see the first, second, and third, and define the padding and the size of the graphic, because you can see there is a gap here. We have a gap from each inside graphs, and we also have the total size we need to define. And the next thing we need to do is define the scale, the total scale, like a x-axis and a y-axis. We need to define the scales of the graph, and in this step we also need to transfer our data set into the numbers without any strings. And since the screen plot matrix has only one scales, we use scale dictionary and define several scales. At the same time, we define axis, SVG graph, and legend. In the main graph, implementing matrix and scatter plot by using the cells, you can see the cells here. And by using the cells and adding the secondary index of a matrix, in the following step, we should do is draw the border. You can see the border here. We draw the borders. We draw the scatters. I draw the dots. Every dot here in each little graphs separately. We each graph separately. I need to read the scale first. We need to read the scale first, and then read the data from the scale. Come from the dictionary. Finally, we define a cross function. We need to cross function and allocate the number of the matrix. Thank you very much.